Hello, math students. Today we are finishing up our Systems of Equations unit, and this video is for if you need an explanation on any part of the review. I am going to do the entire review. Feel free to just watch the parts that you need. You don't have to watch the whole thing. I just want to have this as an option for you in case you get stuck on anything. The first three questions are these multiple choice ones. So I want to make sure that you're clear on this. I know that sometimes with the extra reading, it can kind of seem a little bit overwhelming. So number one says systems of equations that have one solution. That means the lines have to cross. If they have to cross, they cannot have the same slope, regardless of if it's the same or different y-intercepts. If it's the same line or parallel lines, that won't give me one solution. In fact, on this one, C and D both work as long as the lines have different slopes. I don't care if it's the same y-intercept or different y-intercepts. Both of them work. And I know that's not ideal for multiple choice, but I promise on the test it won't be at all unclear on that. If we were looking for no solution, remember that would be where they're parallel, so same slope, different y-intercepts. Now that I'm looking for number two at infinitely many solutions, that's the all points on the line. When you graph that, what we're really looking for there is to have exactly the same line. That one has to be C. And number three, when solving a system by either elimination or substitution. That's just saying if you weren't necessarily graphing it, what does the solution represent? Well, the solution is still the same thing if you're doing it with elimination or substitution or graphing. No matter what, we are talking about the point of intersection for the graphs of those lines. So yeah, I know there's a bunch of C's there, but I promise that's not on purpose. I'm not trying to mess with you or anything. That's just how it happened to be. I had taken out some other problems and the ones that were left were all C's. In 4, 5, and 6, these are really yes or no questions, or solution or not a solution. I'm not asking if there is no solution. I'm asking if the point that I'm giving you is the solution, if it is a solution. So what we're going to do on each of these is we're going to substitute. This is the x, this is the y. I'm going to put it into both equations. So in that top equation in number 4, I'll have 3 and then the x is a 1. There's my y. This is going to be 3 minus a negative 1 or plus a positive. So yes, it does work in the first equation. In the second equation, I'll have 7 times 1, 2 times a negative 1. I want to know, does that equal negative 5? So this is 7 plus negative 2. That's going to be 5. Those are not the same. So if you don't get a yes for both of them, it's a no overall. So number 4 is no, it's not a solution. I know there's not a lot of space there to show your work, but that's what we're looking for. For number 5, again, the x is 2, the y is 1. So I'm going to have 2 plus 1 from the top equation. Yeah, that one works. I don't even need to write down that it's 3 equals 3. You can see that. In the second equation, 2 times 2 minus 3 times 1. Does that equal 1? 4 minus 3, yep, that one's 1 also. So since it works in each of the equations, remember, every single point that gets graphed on a line is a solution for that equation. Since this works in both of these equations, then it's a solution for the system. Yay, yes. Number 6, first of all, I would like you to look at these two equations. They have the same slope. They have different y-intercepts. These are going to be parallel lines. They are never going to cross. I don't care what point you pick. Nothing's going to work. Now, I will still show my substitution. I'll say 11 equals 4 times 3 minus 1. And it works for this first equation. However, when I use the second equation, 11 equals 4 times 3 plus 1. I'll get 11 equals 12 plus 1, which is 13, and that's a no. So no, I'm sorry. The only one that works, that's a weird looking no, I'm sorry. The only one that works was number 5. In these 3 problems, we talked about this when we were going through the lesson and discussing, this was on our second day of graphing systems. What would it look like if I gave you a system that would have one solution or no solution or any real number, all points on the line, infinitely many solutions? When I'm trying to find the second equation to give me one of these different situations, if I want one solution, that means the lines have to cross. My slope has to be different. So you can write any equation you want as long as the slope is not -5. I like to keep these nice and easy. I like to say something like y equals, instead of -5x, how about if I just say y equals x? I don't even have to write a y-intercept. You can pick any number you want to for the y-intercept. I don't care what that is. For number 8, it says write the second equation so that the system has no solution. No solution, remember, that means they have to be parallel lines. So this would be the same slope, but it has to have a different y-intercept. So I would need to have y equals -5x. That part I need. Now, pick a different number to add or subtract, but it cannot be adding 2. That's the only thing it can't be. And again, I said I like to keep these simple. I wouldn't even put anything. It's really a +0 right now, and I just don't need anything besides that. For number 9, if I want to have infinitely many solutions, that means they are the same line exactly. You don't have to get tricky here. You don't have to have any particular work to show for this one. I would just keep it like this: y equals -5x plus 2. If you want to have something like y equals -5x plus 10 minus 8, go ahead, but don't make your life harder if you don't need to. Keep it simple. Substitution method is when we have one variable already by itself. Now, I know we did graphing before we did substitution. It just fit better on the worksheet this way if I put the substitution first. So in this one, I know what the x is. I know half of my answer right now. That's my x. That's going to go in place of my x. So I'll have 5 times -7 plus 3y equals -23. Everything else about the equation stays exactly the same. So I have -35 plus 3y equals -23. And then we'll add the 35. So 3y equals -23 plus 35 is going to be 12. And y will be 4. And remember, I knew half of my answer already. I knew that the x was -7. So this solution, the x is -7, the y is 4. In number 11, this time I know what the y is. That's going to go in place of the y. And I will say this problem is a little bit tricky. I would tend to see mistakes on this. I purposely put this on the review instead of on the test. The subtraction in front of the y is where some people really struggle. I would suggest that we put a 1 right there and even do a keep, change. So I can see that this is going to be -2x plus a -1, and then in parentheses, 2x plus 1 equals 7. So I have -2x plus -2x plus a -1 or -1. These match. They don't go away. Please do not add 2x. That's not okay because they're on the same side of the equation. -2x and -2x is -4x. And then we'll solve that. So x is going to be -2. Now that I know that, unfortunately, it's not like number 10 where I just knew the other half of the answer. I have to substitute this in to figure out what the other part, the y, is. So I'm going to say that y equals 2, and then instead of an x, I'll put in my negative 2. The y is going to be negative 3. So my ordered pair, make sure you put in your x first, negative 2, negative 3. In 12 and 13, graphing these lines, I need slope-intercept form. So for number 12, that first equation, I need to get the y all by itself. I guess. So let me rewrite this up here so I've got a little bit of space to work. We're going to divide, divide, divide. Y equals. Now, I also like this to be in slope-intercept form, so I would put the x thing first. And if I'm looking at the negative 9x divided by 3, I'll get a negative 3x. And 12 divided by 3 is 4, which means I'm going to begin at 4, and I have a negative 3 or a negative 3 over 1 slope. So I'll move down 3 over 1, and there is my line. In the second equation, I need the y by itself. I just have to get rid of the 3x. So I would subtract 3x. Y equals negative 3x plus 2. Now, I want you to notice right now, the slopes are exactly the same, but the y-intercepts are different. You should know at this point this is going to be a no solution. This begins at positive 2. And I have a negative 3 slope. So these lines are close together, but they will never touch each other. Those are going to be parallel lines. This is no solution. If you would graph the two lines, or if you graph the first line and then realize the second line is exactly the same, that's when we get all points on the line. For number 13, this one is not going to be one of our special cases. These two, I'm telling you right now, are going to cross in 1 point. So let me start with the first equation. I'm even going to show just a little bit of work right next to the problem. I'm going to say, let's get rid of this 6. So I really have right now 6y equals negative 3x plus 6, and then divide, divide, divide. It begins at 1, and I have a negative 1/2, negative 1/2, all of a sudden I was doubting myself, negative 1/2 slope, so down 1/2 or up and left 2. There's my first line. The second line, I need the y by itself. Now realize I know the y is on the right-hand side, but it's almost by itself. I just have to get rid of the negative 4. So I'm going to divide, divide, divide. I'm going to sneak a 1 right there. And I'm going to put the y first, just because that's how we're used to seeing it. Negative 1x divided by negative 4 will be a positive 1/4 x. 8 divided by negative 4 will be negative 2. So this will begin at negative 2. And I have a positive 1/4 slope, up 1/4. Or down and left. 4. Right there is my second line. And the point of intersection, the solution, is at 4, negative 1. The next section is about elimination. And I kind of have one of each type of problem that we've worked with. The first one, number 14, I have opposites. These two are ready to be added together because notice the y's. They are exact opposites, a positive 5y and a negative 5y. When I add these two together, gone. Negative 5x plus 6x is 1x, or just x. Negative 15 plus 11 is negative 4. So I now know with that one step, half of my answer. I still have to find the y. I can use either equation. It really doesn't matter which one you use. On my answer key, I use the top equation, so I'll use that one now also. So I'll have -5 times -4 plus 5y equals -15. That's going to be a 20. And then we'll get rid of the 20. So 5y equals -35. The y is -7. So my ordered pair will be -4, -7. In number 15, this time I don't have opposites. If I would just add my two equations together, nothing would go away. Some people do this kind of a problem as a subtraction, as I've mentioned in class, but I don't usually like to do subtractions. I see too many students make mistakes with that. So I'm going to multiply one of my equations by -1. That would change one of my -16x's into a +16x. And you can absolutely go ahead and show a distribution of -1. So for instance, in that top equation, if I wanted to multiply this by a -1, I can distribute that. I'll do that, but then I'm going to change it to the easier way that I like to do this. So that would be a +16x, and -1 times -4y would be +4y, and then -1 times -20 is +20. And then I could just add these two equations together. Instead of doing that work, and realize that is perfectly fine, that's actually the way that it's happening, I just have a little bit of a shortcut. If I change all of the signs in one equation, every single sign, that's the same as multiplying by a -1. So in my top equation, I can say that's really a +16x and a positive, or adding 4y, and a +20, and that's exactly the same result that I had before. Now my x is gone. +4y, -7y, -3y, and 20 minus 11 is 9. So the y is going to be -3. If I know the y, I just need to go back into one of the equations to find the x. And in fact, I kind of like the equation after I changed that top equation because everything is positive now. So let's use that. So I'm going to say 16x plus 4 times a -3 equals +20. Remember, I'm using the changed equation. So I'm going to solve this. So the x will be 2. My ordered pair then, the x goes first, so it'll be 2, -3. For number 16, just multiplying by a -1 is not going to cut it here. I'm going to have to multiply one of the equations by something. The y's would be tougher to get opposites because I'd have to change both of them. The smallest number that 3 and 8 can both go into is 24. I have to multiply both. However, if I look at my x's, the top equation is a +3x. If I can get the bottom equation to be a -3x, they'd be opposites. So I'm going to multiply this equation by -3. Now, I do like my two equations to be right next to each other, so I'm going to rewrite the top equation. And then when I distribute here, let's get that new one. So that'll be a -3x, -9y, and -15. So my x's will cancel. 8y and -9y is going to be -1y equals 1. So the y is actually -1. Once I know what the y is, I need to find the x. I'm going to use this equation right here before it got changed. It'll be x plus 3 times the -1 equals 5. So x is going to be 8. My ordered pair will be 8, -1. The last two problems are the story problems. And the sum and difference ones, so nice. These are seriously like my favorites. when I'm asking for these kind of problems, I want to figure out, we're just going to use x's and y's for my variables. I want to write the equations though, and then it says write your answer in sentence form, and you just say the numbers are, whatever. Please write the equations. I know that some of you are really good at crunching numbers in your head, and you think just by coming up with answers, that's good enough. That's not the point of this. It's not to see how good you are at that. It's to see if you can write equations and solve a system. So when I say the sum of two numbers, that's x plus y, is 57. The difference, that's subtraction. So x minus y equals 15. The y's go away. Remember, x plus x is not x. 1x plus 1x is 2x. I just lost my connection. So I'll have that 2x equals 72 when I add that. I'm just waiting for my smartboard to reconnect. I'll give it a second here and I'll just keep talking for a minute. There we go. So 2x equals 72. So x is going to be 36. If my first number is 36, let me use this equation right here. 36 was the x, plus something gives me 57. So my second number is 21. So the numbers are 36 and 21, not an ordered pair. All right, last problem. 3 bags of apples and 2 bags of pears are $24. 5 bags of apples and 2 bags of pears are $32. How much is each kind of fruit? So let's use A for apples and P for pears. So 3 bags of apples, 2 bags of pears, $24. 5 bags of apples and 2 bags of pears are $32. This is one of those where I need opposites. I'm going to multiply by a -1, or I'm just going to do a change, change, change. And now I can add. This is 2a, gone, equals, this is 8. So A is 4, which means that a bag of apples is $4. The pears, then, if I would use my original top equation, 3 times 4 plus 2 times P equals 24. So pears are going to be $6 a bag. So apples are $4 a bag. I know this is not really a sentence, just trying to save some time. On the answer key, I have that written out in a sentence. So today's problems were to finish up this worksheet. And if you just checked the whole thing, or if you did the whole thing with me, it's done. You should be good on that. The answer key is in Schoology, but there will not be a learning check today in Schoology. The only thing that you need to do is, if there was anything on this that didn't make sense, you gotta let me know. Ask me now, email me, I can help you. If you wait until the day of the test, it's really hard for me to help you then. So let me know what I can do to help you, and have a good day.